Hello, welcome back to the continuing lecture series in investment analysis. Um, this is Dr. Jeff Hong, and in our last video, in our last session, so we discussed basically why we have to use, continuously compounded rate of return because it is necessary and essential to use continuously compounded return to emulate the normal distribution. Okay, so as a next step, we would like to actually verify how exaggerated our scenario analysis is compared to the normal distribution outcomes with the same mean and same standard deviation, right? Which is called, likewise normal distribution, right? And we can check, so we can check, the cumulative probabilities of the likewise normal distribution, right? Likewise means that it has the same mean and the same standard deviation. And what would a normal distribution with the likewise mean and standard deviation would give, right? In cumulative distribution and cumulative probabilities and value at risk. So let's take a look at this. This is you can see now that it's the replica of the table 5.1 we did before for the scenario analysis. But again, in scenario analysis, it is quite artificial and discrete. I mean, all the probabilities are I said, although they normally would take it from the Monte Carlo simulation, but if it was taken from like this top management's or senior executives experience and judgment call, and it would be grossly distorted or stated or understated. So that's why we are doing it with the continuously compounded returns. So first, we know already, the in scenario analysis, right? With four scenarios, we have, already expected returns were given, right? And the under each, right? So the portfolio return, portfolio expected return comes to, this is already given result. The result we have verified and confirmed in the previous example. So we got, 10% as the portfolio expected return and 18.68 for standard deviation, right? Now, if we use, let's do the continuously compounded, and we know continuously compounded return of this, right? Right, is, right, natural log of 1 plus, EAR, right? Meaning, and then all I need to do is simply, copy and paste it, and then the portfolio return by continuously compounded rate will be probability times this, right? Probability times this, and sum everything, right? So to save some columns, I mean, I can add another column here and do it there, but we can because it's a repetitive process. It's going to be this column, right, multiplied by this column, isn't it right? This times this plus this times this plus this times this. So we can take care of it in a single shot. It's called sum product, right? And literally sum product, right? Literally, the name says it all. You are summing all the products, which is basically weighted average, right? Now this times this plus this times this. So this times this is product, and then you are summing them all. So you are basically, highlighting that column, probabilities column, and highlighting this column. It's going to take care of some product. And since I'm gonna lock the probability column. Why? Because that probability will be used over and over when we take also the variance. Okay, so if I do that, there you go. So using the that means using the continuously compounded return, actually under severe recession, right? With that probability and with this return, with this EAR, it will be like this, right? And then weighted average of all of that is 7.89. Now the variance using the continuously compound return will be again, we take the difference between these returns and the mean return average. That's the difference term, and you raise it to you square it. That's because that's by definition variance is the by definition, and I probably that is gone here. By definition, variance is the difference term squared. Sum of squared, right? Sum of the squared difference terms, right? And weighted by the probabilities. I thought I put it here, before, but it's gone. But it's not a big deal. We already know that. I can supplement it later. So that I did, and I will drag it down. What am I doing? There you go. Okay, and then these are the square difference terms. In other words, I'm not going to write it now. And then using, I'm going to copy this. I'm going to use sum product, right? So you see the reason why I lock the probability, column, probabilities column, so that, I can, if I didn't lock it, it's going to point to something that was like, 2 columns to the left. So it's going to point to this. So it's going to be crazy, right? So that's, and I don't need the color, the height to be. Yeah. Why isn't it the same? Yeah, and then what is the variance then? Standard deviation. Standard deviation is simply the square root of the variance, QRT. Voila. So this is the standard deviation of our likewise, continuously compounded returns. But as I did that, these numbers automatically populated. I'm going to get to that later. So let's then, find out what would be the cumulative, probabilities of the likewise normal distribution, right? And the continuously compounded rate was needed for likewise the normal distribution. Now, of course, it's cumulative, and so let's find the cumulative probabilities in the original scenario. In the original scenario, of course, the bottom 5%. Cumulative probabilities are basically the percentile, right? Because percentile goes from the bottom. Bottom 5% is bottom 5, right? And then the second tier, right, will be 30%, 30 percentile, right? Which will be this, sum of that, and let me do it this way. Was there previously, and then, okay, and that will give you bottom 30 percentile, right? Bottom 30%. You drag it down, and sum will have to be cumulative. Sum will have to be 1 because that's probability. And don't forget to put, this is a little housekeeping thing, but don't forget to put bottom border lines. Now, and how do you find the cumulative probabilities using Excel? Cumulative probabilities of normal distribution. There's norm distribution, right? Normal distribution function, right? Using our for our desired our desired X level, which is the what is supposed to be bottom 5% result, right? If under the discrete scenario of under this scenario, and then mean of that distribution, mean of the likewise normal distribution, right? And the standard deviation, And true or one means it's the cumulative distribution function, probability function, cumulative probability distribution function, right? So you hit enter, and then that is the probability of normal distribution. In other words, on the normal distribution, it's not 5%, it's like 0.2%. When you drag it down, these are the do I see? Yeah, there must be. Yeah, these are the probabilities, actual cumulative probabilities under likewise normal distribution. Okay, so these probabilities are kind of not something that would happen in under normal distribution, likewise normal distribution, right? And also value at risk by the scenario, right? The worst case scenario, right? Bottom 5%. Worst case scenario is 37%, but it would be under normal distribution, it would be this, and the probability of that happening is not 5%, but bottom it's 0.2%, bottom 0.2%, right? And under likewise normal distribution, right? If it were 5%, bottom 5%, we use normal distribution inverse, right, function, and then it will give you the z value, z score based on that probability. I mean, if the probability were really 5% for bottom 5%, right, and given this mean and given this standard deviation, it would be something like this, right? If the mean was, on the normal distribution, if the mean was 10% and standard deviation were 18.63, actually it would be negative. Not, bottom 5% would be, like negative 37%, but, negative 20.6. And also using that, if it was under, that EAR, that return. But if we use continuously compounded, right? If you use, continuously compounded return, it would be the bottom 5% would be, right? The bottom 5% result will be, right? Using that bottom 5% probability and mean of the continuously compounded and standard deviation of the continuously compounded return, it would be negative 23.04%. Okay. So bottom 5% would be like this if it were normally distributed, right? And it would be using continuously compound return. It would be this using these discrete returns, right? Discrete return and standard deviation. Okay, so that would graphically what that means is, let me go back here and stop sharing that and sharing sharing the PowerPoint, and it should appear in your. I just found. Yeah, it's there. So comparing the our scenario return and probabilities of our scenario and our likewise normal distribution. The red ones are the probabilities, cumulative probabilities of our the scenario, right? And then using, continuously compounded returns, right? Using continuously compound return, bottom 5% would happen, right? At bottom 5%, you would get, a negative 46% return. But the probability of that happening in the likewise normal distribution is 0.2%, right? Now, and also second tier, right? Mild recession, and under with continuously compounded return, using continuously compound return, the cumulative the return would be negative 11.65%, and this cumulative probability will be 30%, but the likewise normal distribution, probability by likewise normal distribution, will be about 15%, right? And basically, it's telling you what we got already by Excel. I mean, then normal economy or normal growth, the return will be like 13%. According to, using the continuously compounded return, right? And the cumulative probability in the scenario analysis is 70%, but likewise normal distribution probability is, about 61%, right? And economic boom, using, cumulative, continuously compounded return, it would give you, the cumulative probability will be 1, but it's actually likewise normal distribution will tell you the probability will be only about 84%, right? So that's the, that's what we can do. And from this, we can tell, we can confirm, verify and confirm that the our four case scenario analysis gives you a grossly pessimistic, and that's what I said already. Once we calculated that scenario analysis result, it's skewed to the pessimistic scenario, right? I mean, the results are more pessimistic than what it would have been in a likely normal distribution. Okay, so yes, not all fund managers are this mathematically savvy. A lot of. I wonder if you have seen the movie, Wolves of the Wall Street. One of those people, DiCaprio, in that movie, he was just a sales guy, right? Or a con man in a way. He was doing all kinds of illegal things, but a lot of them, Wall Street, if you are, working for Goldman Sachs or J.P. Morgan or BlackRock, and they hire top PhDs in economics, physics, mathematics, statistics, of course, they are less than 5% of that organization. They are, but they are the ones conducting this research. So they are not like the wolves of the Wall Street, because the wolves of the Wall Street are like DiCaprio character in that movie. They are just swindlers, swindlers, con men. And they have, they have animal instincts. So they make this kind of, projection. They make this kind of, oh, this is my gut feeling from my experience, 20 years of my experience. It's my gut feeling. Oh, under severe recession, which has 5% chance, our holding period return will be at 37%, and negative 11%. Look, these judgment called by senior managers, right? And if those senior managers are people like them, people like wolves of Wall Street, not PhDs, in economics, finance, or math, or statistics, but basically, who's from rank and file sales force, right? It's overly exaggerated. Of course, to work for, that movie is overly exaggerated, because to work for, a Goldman Sachs, or BlackRock, JP Morgan, at least you should have a bachelor's degree, at least minimum, even to work for sales, sales side of the sell means, because these are asset management, companies, portfolio fund management. They need to bring in the money, right? They need to bring in the client's money, right? So they have to be a smooth talker, a swindler who talks, a con man like Donald Trump, and just appeal to the ears of gullible people. Ringmaster, circus ringmaster, impresario. These are the people who make a living out of and Leonardo DiCaprio in that movie was just like that, with not even any college degree. Even now, I've seen some back in 1990s, some of or early 2000s, I was a student in my class who was working for Goldman Sachs. I don't know if he was just an intern or a temp, but he was he didn't even have a college degree. That's why he was taking this class at BMCC, and then but he doesn't. How could he work for Goldman Sachs? Well, there generally sales positions generally don't require very advanced level intellect, right? It doesn't require all this. But what does it require? Bringing in the client's money, client management, investor relationships management is a big thing, right? Bringing in clients' money. So it has to, if you meet certain, criteria. I mean, look at all these, high-profile marketing people. They meet certain, especially, a front line of, retail sales. They meet certain, and high-end, sale, like, high-end real estate, high-end yacht, high-end, cars, import cars, high-end. Who are these people? Look at those people. They are like, very groomed, sleek, very sleek, and smooth talkers, sleek talkers. And this student was Irish, and I had Irish accent or English accent, So they appeal to certain clientele, higher end clientele. A guy like this appeals to certain you know, high-end clientele. This is a sad thing, because um, depending on, people still, size up other people by these, superficial things. And the movie, if you, I don't know if you ever watched the movie The Secret of My Success, starring, Michael J. Fox. And Michael J. Fox just got his, MBA or BBA, from a like Midwestern college, and he came to Wall Street. His only connection is, his remote uncle is a CEO of a, and then this he started working as mail, from mailroom, right, mail clerk in mailroom, but uh, he makes connection with going to parties of this elite society, high society parties, and you just make right connection, give right impression to this high-powered clientele, and what it takes is some. Of course, at least in that movie, Michael J. Fox is a college graduate with a business degree, so he can. But sometimes very wealthy people in the high-end clientele are not very, not necessarily, highly intellectual or highly intelligent and highly educated people. Some widow of a very wealthy real estate mogul, right? This woman doesn't know anything, but she gets uh, who was this woman? Who was the widow of a very wealthy real estate mogul, and she left all her. She inherited all the fortune of her late husband, and she inherited. She bequeathed it to her dog, right? Her name was. So this is the reality, right? Very pathetic reality. Some people, the high-end clientele, don't know anything. They just, if someone, appeals to them, there are certain traits like, British accent. There were many, unsolved crime cases where, some, fictitious, English, aristocrat who was, just a con man. This guy was from Germany and, posed as, uh, uh, assumed, English last name and posed as, came came to U.S. as a exchange student and posed as, some, English, aristocrat, and hooked up with this, wealthy woman and then killed her, um, got all her fortune, I mean, so there are some people in even in Goldman Sachs who are good for sales, like for bringing in clients' money, like that character, Leonardo DiCaprio character in Wolves of Wall Street, right? So those people making that judgment call that probability of severe recession like this, mild recession like this, oh, that's really a BS baloney, right? Sometimes it may not be that horrible people like that, because movies are always more exaggerating. But even reasonably educated managers, but they are not all math geniuses. They're not all uh, uh, as sophisticated in quantitative techniques like that. Especially they have risen from sales rank and file, and they are senior managers because they have their because of their uh, contribution to the company. the accomplishments. But we make judgment calls like that, and then it will be deviating from normality, right? All their gut feelings will be deviating 100% deviating from normal distribution, normality. Okay, and even if the actual thing, uh, uh, actual workings of the economy deviate from normality, right? And deviation from normality would be, can be kept by a few things, like skew and kurtosis. Skew means right, deviation from normal distribution, either to the right or to the left. And if it is to the right, it's called negatively skewed. The tail, there's more tail to the left, and there's positive skew. And kurtosis means the height, taller than normal distribution. It's called a lepocortic, and a shorter and fatter distribution called platycortic. And normal distribution, a normal shape of the bell curve is called mesocortic. Okay, and so they are called moments of basically mean is the first moment, right? Mean is the first moment. The standard deviation is the first moment, and the variance is the second moment. This is standard deviation cube called the third moment, and that would be skewness. Third moment. And fourth moment is kurtosis, right? Alrighty, so that's it for this segment, this session. I will see you guys in the next video. Stop recording.